In this lesson, we're going to take a look at acceleration. Now, we know in day-to-day life, we think of acceleration as speeding up. We say when we want to speed up, we want to accelerate. But accelerate doesn't just mean speed up. Accelerate can mean three different things. Acceleration is the rate at which velocity changes. The rate at which velocity changes. Now, what that means is anytime the velocity changes, we have an acceleration. And there's several ways to change velocity. You can do it by changing speed. You can speed up. You can slow down. And the other one that we generally forget about is we can change direction. Now, if you think about riding in a car, accelerations are the motions that you feel. If you're just driving along a straight road at a constant speed, you can go to sleep because there's nothing changing. But if somebody hits the gas and you speed up, or you slam on the brakes and slow down and you go around a corner fast, you get thrown around in your seat because your motion is changing. And it's that change that is an acceleration. So speeding up, slowing down, and changing direction are three different ways that something can accelerate, but all of them are accelerations. Now, we looked at some graphs that showed us some acceleration. Specifically, we looked at velocity versus time graphs. And remember, a velocity versus time graph shows us an object's velocity at every instant in time. It shows us how fast the object is moving and which direction it's moving. So we know anytime we're up here, we're in the away section because that's a positive velocity. And anytime we're in here, we're in the towards section because that's a negative velocity. So remember, velocity is measured in meters per second, tells us how fast the object is going, and the sign of the velocity tells us which way it's going. And we saw some graphs that looked like this. Okay? That line starts at 0, not because it starts at the reference point. We have no idea where this thing started, but because it started at 0 meters per second. It started at rest. And as time went by, it got faster. So initially it was at 0 meters per second. Now it's at some final velocity v. That's not 0. It got faster. And the rate at which it got faster is called acceleration. So if we did this with a second line, and it looked like this, both of those things are similar. The blue line at the top shows that thing moving away, getting faster. The orange line that's lower also shows it moving away, getting faster. The difference is this blue line is getting faster at a greater rate, so it's got a greater acceleration. And in fact, it's analyzing this graph that can allow us to define mathematically what acceleration is. Okay? Anytime we have a rate of change, we're comparing with time. And if we look at this, we're comparing how much the velocity changes to how long it takes, which allows us to say acceleration, which I'm going to say is A, is equal to the change in velocity, delta V, divided by the amount of time that it takes for that change to occur. And if you look at that, the delta V, that's from its initial velocity to its final velocity, that's this. That's rise. And the time it takes is from the 0 time to this time, that's run. And so what we really get is acceleration is the slope of a velocity time graph. Okay? So acceleration is the slope of a velocity time graph. Just like velocity is the slope of a position time graph. So this is just the extension, right, of velocity. So velocity is how quickly position changes, acceleration is how quickly velocity changes. Now what's interesting about this is you don't have to have a negative velocity to have a negative acceleration. So what I mean is if I take and I draw this line down and right, the slope of that line is negative. The velocity is decreasing. So it's still moving away the entire time because it's positive, but it's a negative acceleration because the velocity is becoming less positive. It's headed towards 0. However, I can draw a parallel line down here. That line also shows a negative acceleration. It shows it starting at rest, and now it's not at rest. Now it's moving faster. That means this negative acceleration means that it got faster. It's just got faster in a negative direction. So what we have to remember is negative acceleration doesn't mean slow down. Positive acceleration doesn't mean speed up. Negative acceleration means that the velocity becomes more negative. Positive acceleration means the velocity becomes more positive. And depending on the direction that the object is going, that can mean speed up or slow down.